So this is regarding the second session of the polynomial program. So in the previous session we had already seen regarding the reading two polynomials as well as displaying those two polynomials. So in this session we'll be seeing addition of these two polynomial as well as the final result evaluation of the polynomial expression. So let us see the addition of two polynomials. So before we perform the addition of two polynomial, I need to have a function to compare the node A and B polynomial nodes. That is nothing but I need to compare the two nodes. So if you remember, the two polynomial expressions were 3x square yz plus 2xyz plus 1. So this was the first polynomial, and 3x square y square z plus 3xyz plus 2, this was the second polynomial. So if you just remember the two polynomials what we had discussed in the session 1, this was the first and this was the second. So same thing I have written in terms of nodes over here, how we have done the read operations in the first session. So I've written coefficient, and these all were the exponents of xyz. So again this was the coefficient, exponent of xyz is 1, and then again 1, and then the coefficient, and again this is pointing back to the head since it is circular linked list. So same way regarding the polynomial 2. So now let us see the compare function. Why we are using the compare function is, if the coefficient is higher than this particular node, if it is equal, then we are going to do the return 0. If it is coefficient greater than this, that we have to return that particular answer we are supposed to return. So we need to compare these two coefficients as well as exponentials of these two nodes, and then we are going to perform the addition. So here int compare node A node B. So this is node A and this is node B. Now for example, if A of x is greater than B of x, you'll check over here, A of x is greater than or B of x. Now this is coefficient of A, and this I'm just showing an example how it is getting compared. So you'll see over here, if A of x, this is also this is A of x and this is B of x. So both are equal actually. If A of x is greater than B of x, no. If A of x, else if A of x is less than B of x, no. Else if A of I is greater than B of I, no. Else if A of I is less than B of I, no. None condition satisfy, it will actually return 0. Why? Because all the coefficient over here is minus 1. Next, what will happen? Let us try to, in this operation is used in the addition function, that's why I'm showing this function over here. So again I'll just try to compare over here. You just see over here, I'm just not comparing the coefficient, instead I'm comparing the exponential of x's, y and z. So you'll check for A of x, whether A of x is greater than this, you'll check yes. If it is A of x is greater than B of x, no. Else if it will check for A of y greater than B, this is not satisfying, else if A of x is less than B of x, yes. In our case this both are equal actually, so it will not come this for this particular status. Else if A of x is 2 and B of x is 2, else if A of y is greater than B of y, A of y is 1 and this is no. So even this B of y is 2 and A of y is, this is 1 and this is 2. So this set doesn't satisfy, it will come over here. Else if A of y is less than B of y, A of y is 1, this is true. So this is true, right? So it will return minus 1. So this minus 1, we have the cases in the addition of polynomials. So in case if it is equal, right, all this. Now for example, you compare over here, this coefficient we are comparing from x and x is, compare these two both, we are comparing x and x, yes. If A of x is greater than B of x, doesn't satisfy. If A of x is less than B of x, doesn't satisfy. If A of I is greater than B of I, doesn't satisfy. If A of I is less than B of I, also doesn't satisfy because both are equal. And if A of z is greater than B of z, doesn't satisfy. If A of z is less than B of z, doesn't satisfy. So what will happen? It will go to the, so none condition satisfy, it will return 0 when it is in this particular case. When it is over here also, it will return 0. I'm telling the compare function. When it is over here, it compared x and x, it was equal, then it compared y and y. So this was less than, I mean this is a node A, right? Node A is less than node B, that means it is minus 1. that is -1. So this case was satisfied. Similarly, all the nodes will be compared in such a way. So that's why I'm going to use the compare node A, B. So just remember, in case if A of x means exponent of x is greater than exponent of B of x, or exponent of A of y, all this, like for example A of y is greater than B of y, or else A of z is greater than B of z, then all these cases it is 1. In case all these cases is 1. In case if this is less than, all these are less than, I mean these all terms are greater, okay, then it is -1. In case if both are equal, in the sense of this is equal to this, right, we got all this, then it is 0. So just you have to remember these 3 cases while you're doing the function to compare the node A and node B. So just remember, in compare node A, node B, if A of x, that means exponent of x of node A is greater than exponent of x of node B, then you're going to get 1. Else if exponent of A of x is less than B of x, you're getting -1. Else if A of y is greater than exponent of A of y is greater than B of y, will get written 1. Else if exponent of A of y is less than exponent of B of y, it will written -1. And also you'll compare for, once if it is satisfied over here, it will stop because it will return this particular sum. And else if, again, if you, in case if you got these both are equal, and finally in the z section you got it as something like exponent of A of z is greater than B of z, then again it will return 1. And in case if exponent of A of z is less than exponent of B of z, it would return -1. If both the cases are equal, then it would return 0. So this is regarding the function to compare the node A and node B polynomials. This is the function to attach the node C to the polynomial. So over here you have 2 polynomials, node A and node B. I've just took a sample of 2 nodes, that is node A and node B. Once you're done with this node A and node B, we are going to find the sum of these node B that is stored in the node C. So default this will be set to -1, that is first one head node is there, right, that will be set to -1 itself in the node C. That is, this is for the coefficient and this is for the exponent. So here, you know, these all are pointing to the head, this is all head over here. Okay, after that what we are going to do is, now whatever the sum, we'll compare these 2 polynomials. When we compare these 2 polynomials, you'll see the exponents of both the polynomials. Yes, the exponents of both the polynomials are same. So what we do is we'll perform the addition of those 2 polynomials. So what will be the addition of those 2 polynomials when exponent is same? So it will be 2 plus 3, 5. Coefficient will be summed up, as well as exponents will be remaining same. So this is a new node, that is a sum node that needs to be attached to this particular node, I mean node C over here. Okay, node C over here. So what I'll do is I'll keep this particular node. Finally I have to attach this particular node. To do that attachment of this new addition of the nodes to this particular current node, I should perform the execution of this attach function. So what is there in void attach function? Let us see. In CF int void attach int, CF is for the coefficient, x1 y1 z1 is for the exponents of these, and node star ptr is for this. Currently the node star ptr is pointing over here, so head as well as star ptr is pointing over here. What we'll do is, within this function I'll get node temp. So you know, node temp means it will create for the coefficient as well as x exponent, y exponent and z exponent. And for the link, that is temp is equal to get, now I got temp over here, temp is equal to get node. Temp's coefficient I'm putting the CF. What was the CF over here? Coefficient of this 5. And temp of x I'm putting the exponent of x, exponent of y and exponent of z. Now I need to do the connection between these 2 nodes, right? I need to connect between these 2 nodes. So what I need to do, the memory address of this should be stored over here. Okay, the memory address of this should be stored over here, memory address of this. So what I'll do is star ptr is pointing over here, star ptr link is equal to temp, star ptr link is equal to temp. Yes, I did. Then what I need to do is I need to update again, this will be connected back. Okay, I need to, that is shown in the next code. I just need to update the ptr to this, so that what I'll do is star ptr is equal to temp means memory address of temp is being passed. So star ptr is equal to temp means PTR is anymore this. Why this PTR is getting updated? Because every time now, next, for example, you had a next term. If you remember our polynomial expression we had, again after this I just took one sample. We had 100. If you see over here, we had 100 and 300. When I add, I'll get it as 400. Now that is also new node. Again temp, it is 4000. So again this needs to be attached, right? This needs to be attached. So again I need to get node temp is equal to get node temp's coefficient is equal to CF, temp x is equal to x1, and temp y is equal to y1, and temp z is equal to everything is been run, and pointer is updated over here. So that pointer's link needs to be attached over here. Pointer's link needs to be attached over here. So what is there in memory address of this is, for example, 400. So it will be 400, and then again pointer should be updated over here. So this is regarding how we are going to do the attach. This attach is used for the final sum of two polynomials. After you do the sum of two polynomials, the result whatever you will get, right, of expression of polynomial, final expression, that should be done using the attach function. So you need to remember, before going to add function, that is this function, you should know what is attach function and you should know what is a compare function, because within this add function I'm going to use two functions, that is compare as well as regarding the attach functions. So now let us see function to add polynomial a and b. Function to add polynomial a and b. So what is there in the polynomial a and polynomial b, I'll let you know in the next slide itself. So over here just we'll read node add poly, node a, node b. In this, within this node a, node b is same. I'll write this particular node over in the next slide. So what all nodes I need? Actually I need node start a. I'll tell why these are used. These two are used for the last polynomial, that is some polynomial I use c and last c. C is initially that pointing, last c is, instead of star PTR we have last c, because next it has to move on, right? So instead of star PTR I am having last c. In sum, because to add I need to find the result, and done is equal to 0 as a flag. So if it is done, completed, and then initially start a is equal to a itself, start a is equal to a itself. This, that means node a is there and start a is there. These are the two nodes, node a is there and start a is there, both are pointing to node a. And then a is equal to a link and b is equal to b link. I'll let you know while tracing the section what is a, why I'm doing a is equal to a link and why I'm doing b is equal to b link. And then I'm getting c is equal to get node, and all the c is equal to get, when I get c is equal to get node, this c is being created. Within that coefficient I'm setting -1, x coefficient I'm setting -1, y also I'm setting -1, and z also I'm setting -1 over here, and then last c is also pointing over here. So this is what, you know, in the previous slide if you had seen this section, this is this section, okay, same this section. So that is I'm setting in this particular code. So only these two I need to explain, because while tracing over here I'll take the node structure, that's why I've kept it pending. So just remember, while doing node add poly I required start a, and then you require b, as well as regarding the b you need a b, and then node a and node b is already been declared over here. So I need a as well as b, and then start a, c and last c, and then sum done. I just got this c is equal to get node, and c of coefficient is set to -1, c of x is set to -1, and c of y is set to -1, and c of z is set to -1, and again last c is pointing over here. So over here, if you had seen two polynomials we were read, one was regarding the first polynomial and this was the second polynomial. So if you just go back to the read concept, so we had the polynomials of expressions of 3x square y z plus 2xyz plus 1, and second polynomial was 3x square y squared z, and it was 3xyz and 2. So this was regarding, now we had, this was regarding the two polynomials. Now we had to do the sum of these two polynomials, okay, we had to do the sum of these two polynomials. So we'll come back over here. We had node start a, c and last c, and then we had in sum comma done is equal to 0. Start, so you know this is a, and this is b, because node a and b we had already defined over here, node a and b, okay, and this is start a is equal to a. That means what, memory address of a is being passed to start a, that means start a is also pointing over here. I'll tell why start a is just to reach an end, I'm declaring this start a. So a is pointing over here, start a is pointing over here, head is pointing over here, even head is pointing over here also. So that is regarding these two things. Start A is done and start A is done. This is for the result nodes I'm going to use, and then this is to perform the sum, and this is the flag, and this link should be updated. So we are I told regarding the previous session in the previous slide that A is equal to A link, B is equal to B link. That means what? A is equal to A link and B is equal to B link. A is equal to A link means whatever is it is been attached to this. A is equal to A link means it will point to this. B is equal to B link means it will point to this. That is nothing but here you will have certain memory address of A is equal to A link. So that is actually pointing to this, and B is equal to B link means it is pointing over here. So you did that particular thing. After that you got C is equal to get node. C is equal to get node, and you filled all these things. So you just brought C is equal to get node. I brought C is equal to get node. So -1 I did for coefficient, -1 for x, -1 for y, and -1 for z, -1 for z, and then what I did is last C is equal to C. C is equal to get node. This has been got, and last C is equal to C means even last C is pointing over here. So till now we did in this whatever in the previous this is there, right? So this is the expression. So C is equal to last C means whatever the memory address of this is been assigned to this particular place. So for example, let it be 100. So this has been assigned over here. So this is the structure of how the result is to be built. So let us go to the statement. So we have done with this entire section. Now let us go to the do while loop. Your do is there, okay? Do while loop. Switch, compare A and B. So you know, while comparing A and B, if you remember in the compare statement, if A is any coefficient, like it may be x or y or z, is greater than B is any A is any exponent, it may be x, y or z, or if it is greater than B's exponent xyz, then it is always 1. If it is A's exponents are less than B's exponent, it is -1. If A's exponents and B's exponents are equal, then it is 0. So this was there in our compare. It's not comparing A and B, it's actually comparing the exponents of A and B. If A's exponent was any, it might be xyz, if it was greater, then it is 1. If A's exponent is less than B's exponent, it was minus. If both are equal, then it would be 0. So this was regarding the compare. So switch, compare A comma B, that is node A and node B I'm going to compare. So just compare this particular thing over here. So you have over here A is pointing in this particular node and B is pointing in this particular node. You're going to compare these two, both the nodes, compare A and B. Just see the while comparing, coefficient is fine, you're going to compare the exponent. So 2 and 2 exponent is same, so it is equal. When it comes over here, this is greater, y's coefficient is greater, x coefficient is less. So what is the case? When y's coefficient is greater and x coefficient, compare these two, compare this and this. When x coefficient is less than y's coefficient, then it is less than b, so it will go to the -1 case. So it will come to this particular case, and then it will attach b's coefficient. Attach means, again, you know, temp node will be created. If you just remember the concept of attach, temp, this node will be created. This node was being created and it was attached, and one PTR is updated to this. I'll let you know what is happening over there. So here in the attached node, I have B's coefficient. What is there in B's coefficient? It is 3, and then you have B's exponent x is 2, B's exponent y is 2, and then you have 1. Okay, and then B, this is done the attachment over here. While you do perform attachment over here, what is actually happening is, initially this was pointing to this itself. While you do attachment over here, if you just remember regarding here, star PTR was there. Instead here we have last C. So last C's link, I'm going to attach this. For example, if this memory address is 200, last C is here 200, I'm going to put last C, and then what I need to do, this is temp, right? So temp is equal to last C. Temp is equal to last C means last C will be updated over here. Instead, there in the attach we had star PTR. Here we are going to pass the last C. So this is how you will get, C will be over here itself, last C is getting updated. Just attach and last C will be over here. So this is regarding the how I did the attach function. So attach b is this is again all taking a temp attach. It will go to the attach function. It will fetch all these coefficient as well as the exponents in the temp node and finally attach to this particular existing node. And now b is updated to b link. B link means what? B is equal to b link means whatever is there in this particular b link means, for example, see here, let it be 100, 200, 300, 400, and here also 100, 200, 300, 400. So what is actually there in this particular link? It is 300. So b is equal to b link means it is b is equal to 300. So b will be updated and it will be pointing over here. So b is updated and it will be pointing over here. Now b is over here. Okay, so now again I've done that with that particular case -1 is done. So again it will come back over here, compare a comma b, again do while loop, right? It's not done. I did not reach done until where is done. I have not reached this done. So again it is do while loop. So again it will, within this do while loop, again it will come to do, and then again it will compare a comma b. So when it compares a comma b, a is over here. If you remember, a is over here. It will just compare here 3, not coefficient section, it will compare the exponent. So see the x exponent and x exponent. So which is greater? A is greater. So it will go to the case 1. So if a's exponent is greater than b, it will go to the case 1. So what is there in case 1? It will come here. If start a is equal to a, if start a is equal to a, whether what is start a? Start a is here, a is here, whether that is equal? No. So it will not execute done equal to 1. It will come directly to this particular link. So attach a's coefficient, attach. So attach function will create what? A node, right? A node again with temp node. So whatever is there in a's coefficient, so that is here I'll write, that is 3, and then x exponent, y exponent, and z exponent. So that needs to be attached to this particular node. Okay, that needs to be attached to this particular node. So no longer this will be pointing over here. Okay, so what is there? For example, if this is 300, so this will be pointing over here 300, and this was my temp actually. So attachment is done, 3, 2, 1, 1. That node is been done. And what I did is actually last C's link, I attached the temp, and this will be updated now last C. No longer this will be last C, this will be last C. So this is how I did the attach. So again we did not get done. So what, it came break, again it will go to the do while, again it will go to the do while. So what is happening? We did not reach done statement. Until I reach done, I'm going to do this particular execution. So again switch compare a comma b. Okay, sorry, here I did attach and then I need to update. Attachment is done, a is equal to a link. So a will be pointing to this. A is equal to a link means 300, right? So a is pointing over here. Updated a is pointing over. Updated a is pointing over here. Okay, now again it will come to switch compare a and b. So you know a is here, b is here, a is here, b is here. So what it is doing? It is doing the comparison of x exponent is 1, y exponent is also 1, z exponent is also 1. It is doing the comparison of exponents. So both are equal. So if both are equal, it will go to the case 0. So it came over here case 0. If start a is equal to a, no, start a is somewhere here itself. Start a, if you remember, it's here itself. A is here. If it is that, done equal to 1, but in our case it is not that, so it will come to the else part. Else part, what I have to do? These coefficients are, I mean exponents are same. If exponents are same, I need to add the coefficients of both the nodes. Agree? I need to add the coefficient of 3 as well as 2. So for that I'm going to do sum is equal to a's coefficient plus b's coefficient. A's coefficient plus b's coefficient. So what is a's coefficient? We have 2, and b's coefficient we have 3. Okay, if I attach sum. So what is that? Attach sum. What is the value of sum? We have 5. Attach sum 5, and whatever is the coefficient of a, x, y, z. So here I need to do the attachment. And now last C will be updated over here. Okay, attach sum comma a of a's exponent, y's exponent, and as well as the last C, address of the last C. So what is happening over here? Okay, what is happening over here? So these attachments I'm going to do over here, and this is how I'm going to get the updated last C for this section. Okay, and this is a, why this and last C, because in this link again it should back address of last C, because this link is again back pointing to this first node. Initially it was pointing to this particular first node itself. Okay, so that is regarding the last C. And then what I'm going to do is I'm updating A is equal to A link and B is equal to B link. A is equal to A link and B is equal to B link. So what is happening? A is pointing over here and B is pointing over here. The statement meaning is A is equal to A link. That means what? Whatever is link address is 400, right? That means A will be updated to 400 and B is equal to B link. B will be updated over here. So you got A and B over here. So again we did not reach done. So again this much is done. Again it came. Again it will come to do while. Again it will compare A and B. So while comparing again A and B, these XYZ and this XYZ exponents are same. So again it will go to the case 0. Again it will check if start A is equal to A. No, start A is somewhere over here, A is somewhere over here. It's not possible. Else sum of A's coefficient and B's coefficient. So what is A's coefficient? 1 here and 2 over here. So what will be the sum? 3. So if 3 I'll do the attachment, that new node over here. Okay, so if 3 attach 3 and A of X is 0 0 and 0, and last C again this has been pointing to the first. Now this will be pointing to the first, and this is how you're going to do the connection, and last C will be updated over here. Last C will be updated over here. So this is regarding how I did the attach function. So I did attach. After that A is equal to A link and B is equal to B link. So now updated A is pointing over here and B is also pointing over here. So again it will come to do while loop. It will come to do while loop. Compare AB. All the exponents and this both the exponents are minus 1. Both minus 1 exponents. So both are equal. So it will come to again case 0. Here it will check if start A is equal to A. Yes, now start A is also there only, A is also there only. So done. We are done with this particular expression. So this is how we are going to do regarding the addition. So once you reach to the head itself, this is addition is almost done. Always it's all done. So again A I updated here. So this is end of the link. I mean end of the node where addition has been performed. So done equal to 1. So our do while statement gets end. So after that last C link is equal to C. That means this particular link, that's what I did prior itself. Whatever the link of this particular is been updated back to C. That point back to the head. That's what I'm going to do over here. And then return C. Whatever is this particular result, I mean all the return this particular answer, entire expression I'm going to return. So this is regarding how we are going to do the addition of two polynomials. So don't get confused when you're doing attach B coefficient Bx and B of Z and last C, whatever is there, this attached, this is same node I'm going to pass over here. How you're done. So this function will be performed for the attach, what I explained prior. Okay, and here all these links back to head will be pointing at the end. Actually initially the concept of circular link is when you reach second node, again this has to reach, but everything is been attached, and finally last C link is back pointed to the C since it is a circular. Is it clear with this? So this is regarding the function to add polynomial A and B. Next is regarding function to evaluate the final polynomial result, what we got in the previous session. So here we got this particular polynomial expression, right, this final result. So that we are going to do the evaluate in this particular function. So I'll just write what is the content in that. So we had the content of the final polynomial as expression as -1, again that is initially the head, -1 for the x, y and z, and then we had a link. So I'll just do it this way. Okay, so then I had 3, 2 and 2 and 1, and then again 1 more, and then I had 3, 2, 1, 1, 3, 2, 1, 1, and then again I'll just do remaining 2 nodes. I'll write over here like this way. So we had 5, 1, 1, 1, and then again we had 3, 0, 0, 0, and this was again back pointing over here. So let it be as it is. So this was the result of our polynomial. If you recall, this was the result. You can compare here the last result, what is it that I've written over here. So this was the result. So what is happening, you know, head is been pointing over here, head is pointing over here, as well as PTR also will be current, right? Current pointer also will be pointing over here, head is pointing over here, current PTR is also pointing over here. Okay, and again current is also pointing over here. I'll tell you why I'm using all these. So head is pointing, pointer is also pointing, and node current, it should start from the beginning, so current is also pointing over here. So I need to find the result, so I'm declaring int result, and xyz is to take the values of x, this expression. Now whatever we got 3x square y square z, the result is nothing but 3x square y square z, as well as 3x square yz plus 5xyz plus 3. This is the result. So if you had seen in the previous, I got this particular node, I got this particular node, I got this particular node, and finally what I'm going to do is, finally I'm going to do print. I'm going to do the print over here. So when I give print of this particular node, print C, in the, if you've seen checking the main, I've given print C. So when you give print C, whatever display of this particular node we had done in the first session, right? So that particular of node polynomial A, I've done the display. Same way this also will be displayed in this particular form, Okay, so this was my answer. I got 3x square y square z plus 3x square yz plus 5xy z plus 3. So this same thing I've written over here. Now in this xyz is nothing but to take the values of xyz, I need to evaluate. Okay, and ex, ey, ez is for the exponents of xyz, and coefficient is nothing but these coefficients. Okay, so enter the values of xyz. Let me take the values as 1 1 1. So in the first, while solving itself, I've taken 1. Final answer you're supposed to get is 14, if you remember. Okay, now current is pointing to the PTR link. PTR is over here, current is over here, so that will be, current is pointing to the PTR link. So I'll not write the address over here. So pointing to the PTR link means what? Next node. If you remember, PTR link is next node. So current is over here. Current is over here. Okay, so current is pointing over here. Current is equal to PTR link means PTR link memory address might be this 100. So current will be pointing over here. Okay, so current is pointing over here. So current is equal to PTR link, while current not equal to PTR. So let me give memory address for everything: 200, 300, 400. Okay, and here I'll give 50. Let the memory address of this be 50. What is the current address now? It is 100, while current not equal to PTR. Not PTR is 50. 100 not equal to PTR. 100 not equal to 50. 100 not equal to 50, while current not equal to PTR. 100 not equal to 50. If that is the case, copy the exponents of all those current node. What is the exponents of current node you have? You have 2 of x, 2 of y, and 1 of z. So exponent, current x, what is there in current x, current y, that is nothing but exponents I copied, and also the coefficient of that particular thing, so that is nothing but 3. So I copied all these things, and then I'm going to do the result. So what will be the result now? Result plus equal to this is nothing but, actually meaning is result is equal to result plus these sections. Agree? Result is equal to result plus this section. Now coefficient, what is there in the coefficient? Coefficient is 3 into power of x comma ex means what? X to the power ex, right? X to the power ex. X to the power ex is 2. Here ex is 2, and into again y power ey is 2 into z power ey, that is 1. Now over here initial result is declared 0, and we have read the values of xyz. So what is the value of xyz? It is 1. So it would be 3 into 1 square into 1 square into 1, and this is 0. So what would be the result? You will get it as just 3. So the updated result now will be 3. Updated result now, initially it was 0, now updated result would be 3. Okay, so since again what is happening now, this result is being found. Now current is pointing to the current link, where now updated current will be pointing to this one, current link. So current is equal to current link. So current is having 200. Now updated current is, again it will come back over here. Now what is current now? Current is 200. Current is 200, and that is not equal to PTR. PTR is what? 50. PTR is 50. Yes, it is true. If it is true, copy the current exponents, all the values. So in the second iteration, current exponent of x is 2, y is 1 and z is 1, and coefficient of the second node of this node, current node, is now 3. Okay, so we got those values. So again, the result should be performed. So what would be the result? Result is equal to previous result plus. So previous result we got it as 3. 3 plus, what is the coefficient we have? 3 into x is 1. 1 power again 2 into z is y value is 1, again power is of exponent of y is 1 into 1, again 1 power 1 1. So this would be 3 plus 3, nothing but 6, and then again current will be updated to current link. Now current is pointing over here, current is pointing over here. Okay, is it clear? Current is pointing over here. Now again it will come back to while loop. What is the current memory address you have? 300. We'll check for 300 not equal to 50. Yes, it is true. If it is true, third iteration, I will copy this exponent values of xyz. So exponent value of xyz is 1. If you check here, 1 1 1, I copied here, and coefficient value is 5. I wrote 5 over here. So again result, updated result is 6 now. So result would be result plus, what is the previous result I got? 6 plus 5 into xyz value, you know, 1 into 1 into 1. What is the x power 1? 1 we have, here also 1 we have, here also 1 we have. So I would get the result as 11. I would get the result as 11 in this particular iteration, and again current should be updated to current link. So current will be pointing over here. Again you will compare 400 not equal to 50. Yes, it is true. If it is true, then again for the last iteration I need to write the values of current x. What is the current x of this? It is 0, it is 0, it is 0. I mean exponent values of xyz is 0 0, and last iteration it is coefficient is 3. Again it will come back to this result statement. So result would be, result is equal to result is equal to previous result plus 11 plus, what is the coefficient we have here? 3 into 1 power 0 into 1 power 0 into 1 power 0. You can see exponent always 0, so it would be 11 plus 3, so that is nothing but 14 is the final answer. So if you just check, remember in the question one we solved, we got same answer, 14. And then again current is equal to current link. So when it is current is equal to current link, means, you know, this is back connect, this is node is back connected to this particular node, if you remember, for this particular node. Okay, this node is back connected to this particular node. Now current is equal to current link means current will back point to this particular node. Current is back pointing to this particular node. So while current not equal to PTR, now it is 50, not equal to 50 will be false. So it is end of this while loop. So print result percentage d result. So whatever the 14 answer will be printed. So this is regarding how you are going to evaluate the polynomial expression. So this was the final expression, and then using this particular code we have executed regarding the evaluation of the final polynomial expression. Regarding the execution of this polynomial program, let us see in the code blocks. So now let us see the execution of the polynomial program. So over here, ash include standard, same thing we are written, struct node and then aliasing, and then node is equal to get node, and read the polynomial. So if you remember, read polynomials to represent the polynomial A and polynomial B. And regarding the compare function, we have attach function as well as addition of the two polynomial expressions, code as print, as well as regarding evaluate, and then finally we had the main. So in the main, if you had seen, you had read case 1 for the read poly, case 2 for the read poly, and B print display, and over there add poly, whatever the result we got, right, that the sum of two polynomials, again I'm using C. So if you see C over there, C was happening with the node structure. When I give print C, that would display in, go to the display function and print the C, and then evaluate C, whatever the result you got, that result you're going to evaluate, and finally with the exit statement. So this is regarding the program logic. So let us run this particular program and see the execution part. So the first one is represent the first polynomial. So I'll enter 1, enter the elements of the polynomial. So here you have to just enter the coefficient and exponents in the decreasing order. So if you remember the first polynomial, it was 3x square yz. First polynomial, first node part was 3x square yz. So I'm just entering 3 space 2 and 1 and 1. Do you want to enter the more coefficient? I'll give yes. After that, second node part was actually 2 and 2, 1 and 1 and 1. If you remember, it was actually 3x square yz plus 2xyz. 2xyz, I'll give in. Then again I'll give yes, because the last one, that plus 1, was remaining. So if you remember the expression, it was 3x square yz plus 2xyz plus 1 it was. So I'll enter the coefficient. I gave 1. Then again I'll give the other coefficient as 0 and 0 and 0. Okay, so we are done with reading the first polynomial. So do you want to enter more coefficient? No. Now you try to display this first polynomial. I'll give display the polynomial a, that is third choice. So you can see here, see, we had read 3x square yz, 2xyz and 1x over here. You know why? If it is 1, you need to enter the coefficient as 0, 0. So this is regarding how I did the how I taken the read the first polynomial. Now regarding representing the second polynomial, so I'll give choice 2. So enter choice 2. For that, the coefficient I have to enter, if you remember, it was 3x square y square z. So it is 3, 2 and 2 and 1. 3x square y square z. So 2. Again you want to continue, I'll give yes. So there again next term was 3xyz. So it is 3, 1, 1 and 1. Again you want to continue, I'll give yes. Then again it is 2, 0, 0 and 0. Okay, I give 2, 0 and 0. Again you continue, no. And then again I'll display the polynomial b. So it is again option 4 to display the polynomial. So you can see your second polynomial was 3x square y square z, 3xyz, and then it was 2 plus 2. Next what I did is I done with the representing the first polynomial, representing the second polynomial, displaying the first polynomial and displaying the second polynomial. Now let us do the add. While adding these two polynomial, whatever this polynomial and this polynomial will be added, and it would be again printed the result. So that is regarding add a and b polynomial. So I'll give the case 5. So you can see here our result was 3x square y square z plus 3x square yz plus 5xyz plus 3xyz. So this was our result. After that we did the evaluation of the polynomial. So when you do evaluate, what we are doing, we are evaluating this particular result, that is the final. So I'll click on the evaluate. So you got the choice, enter the values of xyz. So if you remember, while tracing part I had given the values as 1, 1, 1. So I gave the same value. So when I give the values of 1, 1, 1, the result would get 14. You can give any values of x, y, z, and then you can compare the result. So this is regarding the execution part of the polynomial expression. Thank you.